Alrighty. Hey, ladies and gentlemen, this is Miss Humbert here, and today we're going to be doing Unit 5, Notes 5. So we're going to talk about quadratic application. So we're going to take what we've been learning with quadratics, and we're going to apply it to some word problems. So taking a look at number 1. Number 1 says that the height h of an object t after it is propelled upward with an initial velocity v is represented by, and then it gives us the quadratic, h is equal to negative 1/2 gt squared plus vt plus h, where g is the gravitational pull and h is the initial height. So we're going to suppose that an astronaut on the moon throws a baseball upward with an initial velocity of 10. Now that's going to represent our v. Okay, then it says letting go of the ball 2 meters above the ground. That's going to be our h. And the gravity constant on the moon is 1.6. That's going to be our g. So let's plug it into that. So we want to figure out when it's going to hit the ground. So that's going to be equal to 0. So I have 0 is equal to negative 1/2. Then I'm going to multiply in my gravity constant, which is 1.6. Then all of my t's are going to stay in there. I'm going to put in my velocity, which is 10, and then my height, which is 2. So now what I'm going to do is I'm going to go ahead and simplify this out just a smidge. So I'm still going to have 0. Negative 1/2 times 1.6 is negative 0.8, and then t squared plus 10t plus 2. So now what I'm ready to do is I'm ready to use the quadratic formula to solve this. So remember that a is always with the squared term, b is always with the t term, and c is always the constant. So I get that t is equal to opposite of b plus or minus the square root of b squared minus 4ac, all of that over 2a. Okay, so now let's go ahead and let's simplify that out a little bit. So we have negative 10 up top. Then the next thing I'm going to do is simplify what is underneath the radical. And when I simplify that out, I end up getting 125.6 divided by a negative 1.6 when you multiply the two of those together. So now I need to go through and create my plus and my minus version. So I'm going to do negative 10 plus the square root of 125.6 divided by negative 1.6. And once I divide those out, I end up getting a negative 0.75. Well, guess what? Time is never going to be negative. So that one is not going to work out. Now I'm going to try the other version, the minus version, negative 10 minus 125.6 divided by a negative 1.6. And when I simplify that out, I end up getting 13.25, and then that's going to be seconds. So that does make more sense. So it actually takes the ball 13 seconds to come back to the ground. That's a really long time, and that's partially because the gravity constant on the moon is so small. So let's take a look at this one. So it's from the same height. So if you remember from the original part of the problem, our h is 2. And the same velocity, our v was equal to 10. But now we want to use the Earth's gravity constant, which is much larger. It's 9.8. So now we're going to plug it in and figure out when it hits the ground. So I get a negative 1/2. Now, instead of the g, I'm putting my gravity constant, which is 9.8. And then I have t squared. Then I'm going to do my velocity. So I'm going to have plus 10t. And then I'm going to add my height of 2. So now I'm ready to go ahead and put this into, or let's multiply it out first. Come on, Miss Humbert. So when you multiply out the top, negative 1/2 times 9.8 is a negative 4.9 t squared plus 10t plus 2. So now what I want to do is plug that into the quadratic formula. So t is going to be equal to opposite of b plus or minus the square root of b squared. Oops, that is a squared. B squared minus 4 times a times c, all of that over 2 times a. So now we want to go and simplify some things out. So I want to calculate what's underneath the radical first. So when you calculate what's underneath the radical, you end up getting 139.2. 2. And that's being divided by 2 times negative 4.9. And when you multiply those two together, you end up getting a negative 9.8. Okay? Okay? Versions, negative 9.8. So now let's go ahead and let's do that. So we get negative 10 plus the square root of 139.2, and then we're going to divide that by negative 9.8. So I want to calculate out the top first. Negative 10 plus the square root of 139.2, hit enter, and then divide that by a negative 9.8. So when I divide that out, I end up getting a negative 0.12. You should be calculating this along with me to make sure you're doing it right as well. Well, I can't have negative 10, so now let me try the minus version. So I'm going to do negative 10 minus the square root of 139.2, hit enter, then divide it by a negative 9.8. And when I do that, I get 2.42. Now that's going to be my answer, so I want to make sure I label it seconds. So that's my final answer for part B. Now let's take a look at number 2. Hopefully that paused. What's up?
Where can we find the stuff with the blood drive? Is the table's there but no paperwork?
Check with Miss Johnson. Her room's 3305. The bin should be in there if it's not out there, okay?
Okay.
You're totally fine. Thanks for checking in. No worries. Okay, so now we want to figure out a projectile shot vertically up in the air from ground level. Its distance s in feet after t seconds is given by s is equal to 96t minus 16t squared. So we want to figure out when s is 96 feet. So what we're going to do is we're going to plug in 96 for s. So then I end up getting this. Okay, so then what we're going to do is we need to actually solve this for t. So I'm going to go ahead and subtract 96 from both sides. So then I would need to put it in standard form. So the first thing I'm going to write is my negative 16t squared, then my 96t, then my 96. So now what I need to do is do the quadratic formula to solve for t. So I'm going to get that t is equal to opposite of b plus or minus the square root of b squared minus 4 times a times c, all of that over 2 times a. So now I'm going to calculate underneath the radical first. So I'm going to do 96 squared minus 4 times negative 16 times negative 96. And that's going to give me the square root of 3072. And that's going to be divided by a negative 32. So I get negative 96 plus or minus the square root of 3072 divided by a negative 32. So now first thing I need to do is my plus version. So I'm going to do negative 96 plus the square root of 3172 divided by negative 32. Remember, you want to completely calculate out the top, then divide it to get the bottom. So that's going to be 1.27 seconds. So that's one of our solutions. Then we're going to go ahead and do the minus version. So doing negative 6 minus the square root of 3072 divided by a negative 32. When I do that, I get 4.73 seconds. So now you're probably thinking, hey, I got this 2 times for an answer. Well, think about the motion an object takes. It launches into the air and then it comes back down. If this represents 96 feet, it could very well hit 96 feet twice. It only hits the maximum height once and the ground once, and that's what we've been calculating for the most part up to this point. It, however, can reach specific heights twice if they're both on the trajectory path. So let's take a look at number 3. A pan is formed by cutting 2 centimeter by 2 centimeter squares from each corner of a square sheet metal and then folding the sides. If the volume of the pan is to be 441 square centimeters, what should the dimensions of the original piece be? So what we're going to do is calculate out the volume. So the base of this box is x minus 4 times x minus 4. So we have 2 times x minus 4 times x minus 4, and that's going to be equal to the volume, which is 441. So the first thing I'm going to do is distribute the 2 into just the first parenthesis. Okay? Then what I want to do is use the box method to multiply this out. So I have 2x minus 8 and x minus 4. So 2x times x is x squared. Negative 8 times x is negative 8. That should be negative. Okay, yep. 2x times negative 4 is going to give me negative 8x. And negative 4 times negative 8 is a positive 32. So what I have here is 2x squared, and then when you add 8x minus 8x, you get negative 16x plus 32 is equal to 441. So now I need to subtract that 441 from both sides. So then I get 2x squared minus 16x, and then that's going to be a negative 409 is equal to 0. So now that I've subtracted that over to the other side, I am ready to use my quadratic formula. So x is equal to the opposite of b plus or minus the square root of b squared. Again, noticing I'm putting that negative number in a parenthesis. Minus 4 times a times c all over 2 times a. So then I'm going to get 16 plus or minus the square root. So we're going to do 16 squared minus 4 times 2 times negative 409. And underneath the radical, that's going to give us 3,528. Now that's going to be divided by 4 because that's 2 times 2. So now what I need to do is, first thing I'm going to do is my plus version. 16 plus the square root of 3,528. And then I'm going to type that in and hit enter. And then I'm going to take that answer and divide it by 4. So when I do that, I get 18.85. So that could potentially be one of our distances. Then I'm going to do 16 minus the square root of 3,528. Again, you want to type that in first. Hit enter, see what you get, and then divide it by 4. And you end up getting, when you do that, so we get 16 minus the square root of 3,528. You end up getting negative 10.85. Well, we can't have a negative distance. So what we end up getting is 18.85. So what we're going to do now is we have a box that's x minus 4. Well, x is 18.85. So we're going to take that and subtract 4. So 18.85 minus 4 is going to be 14.85. So the bottom of the box is 14.85, and that's going to be multiplied by 14.85 times the height of the box, which is 2. Now all of that is centimeters. So that's your final answer for number 3. Let's take a look at number 5. Jimmy John's is tracking the sales of its subs. The manager sees that the quadratic representing this is y is equal to negative 25x plus 250x plus 400. So it wants us to get the maximum revenue. So to do that, we need to calculate out the vertex. Remember that the vertex is opposite of b over 2 times a. So then I get negative 250 divided by a negative 50, which gives me 5. So 5 is what I'm going to plug in for each of those x's up there. So I get y is equal to a negative 25 times 5 squared plus 250 times 5 plus 400. And when you type that into your calculator, you end up getting 1,025. So the vertex is 1,025. So the y coordinate always represents the maximum money, the maximum profit that you're going to make. So the maximum revenue is going to be $1,025. So that is your answer for part B, and that concludes your note video for today. Thanks for listening.